How does C++ debugging help identify runtime errors? Have you ever wondered how C++ debugging can help you find those pesky runtime errors that pop up while your program is running? Let's break it down and see how this process works. C++ debugging is a key tool for spotting and fixing runtime errors. These errors happen during the execution of your program and can be trickier to find than compile-time errors. Debugging tools allow you to observe your program in action, giving you a chance to see what is happening in real time. One of the first things debugging does is allow you to run your program step by step. This means you can execute your code line by line. If something goes wrong, you can see exactly where the program deviates from what you expect. This step-by-step execution is a game changer for identifying issues. Another important aspect is inspecting variable values. During debugging, you can check what is stored in your variables at different moments. This helps you find invalid or unexpected values, like null pointers or uninitialized variables, which can lead to runtime errors. Memory issues are also common culprits for runtime errors in C++. Debugging tools can help detect memory leaks, buffer overflows, and dangling pointers. These problems often cause your program to crash or behave unexpectedly. Using specific libraries designed for runtime error detection can also be very helpful. The C runtime debug libraries provide functions that monitor memory usage. By linking your program with these libraries, you can automatically check for common errors, like accessing invalid memory. When you debug, you can identify specific runtime faults. For example, if your program tries to divide by 0 or access a null pointer, these actions will lead to runtime errors. By observing crashes or exceptions during debugging, you can catch these issues early. More specifically, debugging helps you locate the exact line of code that causes the error. When you run your program under a debugger, you can see where it crashes. This is often much clearer than just reading through the code. You also get to understand the state of your program at the moment it fails. Debuggers show you the call stack, variable states, and memory contents. This information is crucial for figuring out why the error occurred. For complex bugs, tools like AddressSanitizer can help detect issues like stack smashing or buffer overflows. These tools work alongside your debugger to provide more detailed information about what is happening. Preventing errors is another benefit of debugging. Some methods include using static analysis tools that analyze your code for unsafe constructs before you even run the program. This can help catch potential runtime errors early on. Assertions and debug macros are also useful. You can include assertions in your C++ programs that check assumptions at runtime. If an assumption is violated, the program will halt and report an error. Debug macros help track memory allocations and identify leaks. In practical terms, mastering C++ debugging means learning to use these tools effectively. This skill allows you to quickly identify and fix runtime errors, saving you time and improving the reliability of your software. By stepping through your code, inspecting variables, and using runtime checks, you can isolate bugs like null pointer dereferences and division by 0. In summary, C++ debugging transforms runtime errors from frustrating mysteries into manageable issues. By providing visibility into your program's execution and memory state, debugging enables you to fix bugs effectively and build more robust applications.